Hello everyone. In this video, we talk about the law of total probability. Consider a sample space with event B1, B2, and B3. These three events are collectively exhaustive and mutually exclusive. Suppose we want to get the probability of event A. One way of computing the probability of event A is to look into each partition of S and then add up the probability of A that falls in that partition. For example, in partition B1, the probability of A that falls in this partition corresponds to the probability of the intersection of B1 and A. So similarly, for partition B2, we have the intersection of B2 and A. And for partition B3, we have the intersection of B3 and A. So the probability of event A equals the probabilities of these three intersections. However, we may not know the probability of the intersections directly. Instead, we may be given the conditional probability of event A given, say, partition B1 has occurred. So we know the probability of A given B1. And by the definition of conditional probability, this probability of A given B1 equals the probability of the intersection of B1 and A divided by the probability of B1. From this formula, we can get the expression of the probability of the intersection of B1 and A. The expression equals the probability of A given B1 times the probability of B1. Similarly, for partitions B2 and B3, apply the conditional formula. The probability of A given Bi, where I equals 2 and 3 respectively. And then we can get the expression of the intersection of B2 and A and B3 and A respectively. And then we can get the formula in computing the probability of event A using conditional probabilities as shown at the bottom of the PowerPoint here. And this is the law of total probability. We can do a general form of the law of total probability. So here assume that B1, B2 up to Bn are collectively exhaustive events where the probability of Bi greater than 0 for I equals 1, 2 up to n. And events Bi and Bj where I not equals to j are mutually exclusive. So for any event A, the probability of A equals the probability of A given B1 times the probability B1 plus the probability of A given B2 times the probability B2 plus up to the probability of A given Bn times the probability of Bn. And this is the general form of the law of total probability. Let's take a look at an example and see how the law of total probability can be applied. In a college, the number of junior students is 4 times the number of senior students. The probability that a junior student will be pursuing a major in data science is 0.25 when the student transferred to a university. And the probability that a senior student will be taking data science as a major is 0.45. Let's construct a Venn diagram. And then let's fill out the numbers in terms of probabilities. So from the first statement of the question, the number of junior students is 4 times the number of senior students. We have the probability of J. Here I denote this event J as junior student equals 0.8. And then I define event S to be the senior student. So I have the probability of S equals 0.2. And then we have 2 more probabilities mentioned in the questions. The probability that a junior student will be pursuing a major in data science is 0.25. Here I define event D, where the student will take data science as a major. So here we have the probability of D given J equals 0.25. And then from the last statement in the question, the probability that a senior student will be taking data science as a major is 0.45. Then we have the probability of D given as equals 0.45. Let's take a look at a questions related to this example. If a student is selected randomly, what is the probability that the student is a senior student and he chooses data science as a major? So what we are interested in is this shaded part in the Venn diagram. The student is a senior student, and then he chooses data science as a major. So we need to compute the probability of the intersection of S and D. So from the 4 given quantities, only P of S and P of D given S are relevant in this question. So how do we compute the probability of the intersection of S and D? We can make use of the conditional probability formula. The probability of the intersection of S and D equals the probability of D given S times the probability of S. These two probabilities are already given in the questions. The probability of S is 0.2 and the probability of D given S is 0.45. So multiplying together, we get the probability that the student is a senior student and he chooses data science as a major is 0.09. Let's move on to the next question. If a student is selected randomly, what is the probability that the student chooses data science as a major? Here, we don't care whether the student is a senior student or a junior student. So we are interested in whether the student chooses data science as a major, and we want to get the probability that the student chooses data science. So this corresponds to the two shaded region in the Venn diagram. So here we want to get the probability of D. We are given some conditional probabilities, so we can make use of the law of total probability to compute the probability of D. So the probability of D equals the sum of the probability of the intersection of S and D, the senior student taking data science as major, plus the probability of the intersection of J and D, the probability that the junior student take data science as a major. So the probability of D equals the probability of the intersection of J and D plus the probability of the intersection of S and D. This is by the law of total probability. And then for the two intersections, whose probability can be found using the conditional probability formulas. So the probability of the intersection of J and D equals the probability of D given J times the probability of J. And the probability of the intersection of S and D equals the probability of D given S times the probability of S. The quantities are given in the questions. So we have Pj equals to 0.8, and then Ps equals to 0.2, and the two conditional probability, the probability of D given J equals 0.25, and the probability of D given S equals 0.45. substitute the numbers into the formulas, we get the result. The probability that the student choose data science as a major equals 0.29. Let's move on to the next question. If a student is selected randomly, what is the probability that the student is a junior, given that she chooses data science as a major? Okay, so identify the correct region. So here we are given that the student choose data science. So only the data science portion is relevant now. And this is the reduced sample space. And from this reduced sample space, we want to get the probability that the student is a junior student. That is, we want to get the probability of J given D. What is the expression? By the conditional formula, the probability of J given D equals the probability of the intersection of J and D over the probability of D. And the probability of D equals the sum of the probability of the two intersections, the intersection of J and D and the intersection of S and D. And we have these two numbers we computed previously. The probability of the intersection of J and D equals 0.25 times 0.8. And the probability of the intersection of S and D computed previously, this equals 0.45 times 0.2. So we get these expressions. The probability of J given D equals the probability of the intersection of J and D equals 0.25 times 0.8. And then divided by the probability of D, we computed as 0.29. So upon calculations, we get the probability that the student is a junior, given that she chose data science as a major, equals 0.6897. That's it for this video. Thank you for watching. In the next video, we will talk about the Bayes theorem.